In this video we want to begin to look at Chapter 1, Section 3, and what we're talking about in this section is solving equations with variables on both sides. And our question is, how do we solve equations with variables on both sides? So the basic strategy is that we're going to collect all of the variable terms on one side of the equal sign and all of the constant terms, that is the numbers, on the other side of the equal sign. So there are different ways of going about this. You don't have to use the same strategy every time. Some people like to use the same strategy every time. It makes it easier, less things for them to remember. So I'm going to begin with the first example, which is 8a plus 96 is equal to negative 24a. Two ways we can go about this. One way says always move the variable to the left side. So let's see how that works. So if I want to get rid of the negative 24a on the right side, I can simply use the inverse operation to add 24a on both sides. That gives me 32a plus 96, and then what some students have difficulty with is understanding what's on the other side. It looks like there's nothing there, but in fact negative 24a plus 24a, and whenever we add two opposites together, we're always going to get a 0. So it's okay, just because there's nothing there doesn't mean there's nothing there. Actually, there's a 0 over there. Now we would subtract 96 on both sides, and we end up with 32a is equal to negative 96, and at this point we can divide both sides by 32, and you'll see that a is going to equal negative 3. So that does it for example 1. All right, we'll go on to the second example here. Second example says 0.2 times the quantity, in parentheses, 10b plus 60 has got to equal negative 4 times b minus 12. And according to our strategies, our list of strategies to solve multi-step equations, one of the first things we need to do is to distribute. So we're going to distribute 0.2 times 10, and that is simply 2. Sorry, it's 0.2 times 10b, giving us 2b, and 0.2 times 60 gives us 12. On the other side, so we need to distribute here. On the other side, we're going to distribute the negative 4 times b and negative 4 times negative 12, or positive 48. So at this point, again, we have an equation that has variables on both sides. If I want to use the to the left strategy, all I need to do is add a 4b on the right, do the same thing on the left, and I have 6b plus 12 on the left and 48 on the right. At this point, we know that we're going to subtract before we divide, and we have 6b is equal to 36 dividing by 6, and we have b, which looks an awful lot like a 6, but it's not. B is equal to 6. And so that's the answer to our second equation there. So try to follow those steps, and if you need to, you can rewind and replay that section again. The next. Now, so those are examples of solving multi-step equations with variables on both sides. Something else that happens when we have variables on both sides is we get two special cases of equations, and we'll take a look at example 3 here. Shows us one of those special cases. Well, we have 3 times 2m plus 4 is equal to 2 times 3m plus 6. When we multiply this out by distributing, we're going to get 6m plus 12 is equal to 6m plus 12. Well, we can stop at that point. Whenever we have exactly the same thing, and it has to be exactly the same thing on both sides of an equation, then it doesn't matter what value we put in for the variable. We could put m equals 0 and we'd get 12 on each side. We could put m equals 1, we'll get 18 on each side. We can put m equals 2, etc. 3, 4, any value, integer, real number, decimal, it doesn't matter. Whatever we put in there for m, both sides will always be the same. So we say that this is always true. And because it's always true, there are infinite solutions. It doesn't matter what we put in. We have an infinite number of values of m that we can substitute, and we'll always get a true statement. So this is the first type of special case of equation that we can have when we have variables on both sides. All right, the second type of equation that we can get when we have variables on both sides is similar but slightly different. So let's take a look at it. And I'll write it on this side over here. I have 4y is equal to negative 2 times the quantity 6 minus 2y. Now I only have distribution on the right side, but when I distribute the negative 2, I'm going to get negative 12, and then negative 2 times negative 2y is positive 4y. Alright, so at this point I can see something doesn't look good. It says 4y is equal to negative 12 plus 4y. But how can 4y be equal to 4y minus 12 or negative 12 plus 4y? So what I would do in this case is use my to the left strategy. And when I do that, you're going to see on the left side I get 0 because I added two opposites. And on the right side I'm going to get negative 12. So here I have an interesting equation. It says 0 is equal to negative 12. Well, that doesn't make sense because 0 is never equal to negative 12. And so we'll say this is never true, just like the other one was always true. This one is never true, and therefore we have no solutions to this equation. No solutions. Oh. All right. So when we have equations on variables on both sides of the equation, we can use a strategy such as to the left, always to the left, and we collect our variables on the left side of the equal sign, and we move all the constants by addition, subtraction, multiplication, division to the right side. A second type of case that can happen is that we can either have infinite solutions or no solutions. So those 4 examples highlight these different cases that come up when we have an equation with variables on both sides.